Conduction velocity of nerves in the frog. In this experiment, we will calculate the conduction velocity of the nerves of the frog. Principle. The velocity of conduction of nerves in the frog is determined by using the formula velocity is equal to distance divided by time. We stimulate the sciatic nerve at its vertebral end with the stimulating electrodes. We mark the point on the nerve at which the electrode is applied. We record the muscle twitch on the graph paper. Now, we place the stimulating electrodes closer to the muscular end of the nerve. We mark the point on the nerve where the electrode is applied. We stimulate the nerve and record the muscle twitch. We measure the distance between the 2 points of stimulation on the nerve accurately. We can now use the graph to calculate the velocity of conduction of the nerve. Using the graph, we measure the latent periods in both the muscle twitches. The latent period for the muscle twitch stimulated from the muscular end and the latent period for the muscle twitch stimulated from the vertebral end. The latent period for the muscle twitch stimulated from the muscular end is less than the latent period for the muscle twitch stimulated from the vertebral end. We calculate the difference between the two latent periods. This gives us the time taken for the nerve impulse to travel the distance between the 2 points of stimulation on the nerve. We already know the distance between the 2 points of stimulation. Now it becomes easy to calculate the speed or velocity of conduction of the nerve using the formula velocity is equal to distance divided by time. Thus, the conduction velocity is equal to the distance between the 2 points of stimulation on the nerve divided by the difference between the two latent periods. Normally, the conduction velocity of the sciatic nerve of the frog is 40 to 60 meters per second. The conduction velocity of a nerve depends upon two factors: the diameter of the nerve fiber and the myelination of the nerve. The greater the fiber diameter, faster is the conduction through the nerve. Myelinated nerves conduct impulses much faster than unmyelinated nerves. This is because the current jumps from one node of Ranvier to the next in the myelinated nerves.